For our Chapter 3 practice test, we're going to be having two problems that go from our first learning target, solving by graphing. Obviously, we want to have y equals mx plus b. If you look at number 1, there's a negative 1x. That means your m is negative 1 over 1. Its slope, it tells us we have to go down 1 and we have to go 1 to the right when we move from one point to another. Our b is going to be a 2. B is our y-intercept. This is where we begin. We're going to go 2 steps above the origin. We'll go down 1, right 1, down 1, right 1. Continue with this pattern. Label as many points as you can. You can also continue this pattern backwards as if it were positive 1 over negative 1. Go up 1, left 1. And part of what we're doing here is actually making a nice graph, not just writing a simple answer. For our second line, m is 2, but we can think of that as 2 over 1. That gives us direction for slope. We'll go up 2, right 1. Our b value is negative 4. So I'll begin going 1, 2, 3, 4 steps below the x-axis when it's negative. I'll go up 2 steps, right 1. Up 2 steps, right 1. And here we can see this is the point of contact. We've already labeled it or drawn it. Go up 2, right 1. You can continue that pattern. But regardless, I hope it's very clear that the point of intersection that we're really talking about is this one. Be careful that you write your solution appropriately. This is the point 2, comma 0. As we take a look at number 2, very, very similar situation. We could see that our first line has an m of 1. That's 1 over 1. We're going to go up 1. We're going to go right 1. We have a b of negative 3. So I will begin by going 1, 2, 3 steps down. My slope tells me to move up 1, right 1. And we'll continue to move up 1 and 1 to the right, as well as going down 1 and 1 to the left. You can very quickly see a line taking place. The second equation, however, is going to take a little bit more effort. I don't have y all by itself. I need to solve for y. I always add or subtract first. I will add a 2x. I'll have 2y is equal to 2x minus 6. Let me re-copy this line right over here. It only takes a moment as you're solving. When you divide by 2, you're quickly going to see that you have the same line. You have y equals x minus 3. No sense graphing it a second time. You can put little dashes right by it. This is when we have infinitely many solutions. When our lines are identical and they're actually intersecting at every point. For number 3, as we use substitution, please understand that we have another name for x. So when I write negative 2x plus 3y equals 1, this x can be interchanged for a 5y plus 10. Another name for x is 5y plus 10. We're just going to replace x with that expression. Notice I am putting parentheses around it. As I distribute this negative 2 times 5y is negative 10y. Negative 2 times 10 is negative 20. It's at this point that we have to be very, very careful. You want to combine like terms. Negative 10y plus 3y would get you negative 7y. And really this plus negative 20 is the same thing as a minus 20. I can add 20 to both sides. And we'll have negative 7y is equal to 21. I'll divide by negative 7, and I'll get y is equal to negative 3. Now we're not done, of course, because we still need to find out what x is. X, from the very beginning, was 5y plus 10. But now I'm going to plug in my y value of -3. And 5 times -3 is -15. -15 plus 10, you can quickly arrive at -5. Notice that the answer I'm going to write down is going to be as an ordered pair, as the point -5, comma -3. As always, if you're nervous about this, you can plug this point in to check it for both of your equations. Let's move on to number 4. A very, very similar kind of a setup. Here we have 3x plus 2y equals 1. But we have another name for x. That is 2y plus 3. And as we substitute that in, as we rewrite x as 2y plus 3, you can quickly see that we can distribute. We would get 6y plus 9 plus 2y equals 1. Notice again that we want to combine like terms. That's such a critical step. 6y plus 2y add up to 8y. So I have 8y plus 9 equals 1. I'm going to subtract a 9 from both sides, so I can arrive at 8y equals -8. Then I can divide by 8 to arrive at y equals -1. Of course, we're not done. We always need 2 variables to arrive at a final answer, and I'm going to plug that y value of -1 right in here. We'll have 2 times -1 plus 3. -2 plus 3 will arrive at just a +1 for x. So your x comma y would be 1 comma -1. And again, if you're ever worried about that, you can go back to the original 2 equations. You can plug in your point to double check that it truly is a solution. One more and then we'll wrap up this video just going by this first page. We have 5x plus 3y equals 9 for our second equation. But look at what we have for the very start. We have another name for y. We can say, look, instead of writing y, we can plug in 3x minus 4. And we can do that right now. It's 3 times y in that second equation, but this y is really 3x minus 4. Now there's a little surprise here. I think a couple of kids were really bothered that things don't work out to a whole number here. And that's okay. As you distribute, 3 times 3x is 9x, and 3 times -4 is -12. 5x plus 9x is 14x. And then I can add a 12 to both sides. 9 plus 12 is 21. So let me just recopy that up here. This is where kids can fear the worst. They can think, wow, I must have done a mistake. In all honesty, this is perfectly okay. 21 divided by 14, look, that is, of course, a fraction, and you can always do an alpha y equals to reduce that fraction if you'd like. By the way, a decimal would be just as good in this regard. But 21 over 14, you'd get 3 halves, 3 over 2. Your y value, of course, was 3x minus 4. So very simply, we can plug in that x value of 3 halves and more or less just get our answer directly. You can go back to the calculator, of course, and probably get your answer most quickly in that way. Decimals are also okay. Please understand that would be perfectly acceptable as well. Your answer is 3 halves, comma 1 half. If you wrote that as a decimal, it would have been 1.5, comma 0.5. Well, we'll wrap up here. This was our first page of our practice test.